Imagine buying a new smartphone, electric car, laptop, or other electrical device without having to worry about charging it. Consider the potential of using the same battery for the rest of your life and then passing it on to your children or other relatives. Imagine a future without cables or the concern of running out of battery power in your phone or automobile. Wouldn't that be a fantastic idea? This is now possible because to the development of a new kind of battery that uses nuclear waste from reactors to create energy, which can then be used to power all modern devices. A single charge of these batteries will power them for about 28,000 years. NDB, a California-based startup, created the nanodiamond battery, a totally nuclear battery that uses radioactive isotopes used in nuclear reactors. We have a wide range of battery-powered technical equipment. It must be recharged at least once a day while in constant use. What if a battery that didn't need to be charged was invented? That sounds too good to be true, yet it could be true. That is the promise made by NDB about a new battery technology that uses nuclear waste to create power for thousands of years. Today, we'll look at the game-changing nuclear diamond batteries that have the potential to change the whole electric industry. But first, we are giving away $100 to one of our lucky subscribers. All you have to do is watch the entire video, leave a comment with your greatest takeaway, like, share, and subscribe. So, without further ado, let's get started. Batteries play numerous important roles in everyday life, from providing the initial power needed to start the engines of cars to acting as a backup source of electricity in telecommunications, public transportation, and medical procedures. Batteries also have the potential to help reduce greenhouse gas emissions by efficiently storing electricity generated from both conventional and renewable energy sources and as a source of power for electric vehicles. We have an inexpressible need for energy. When we need to run anything that cannot be simply plugged in, we will need to use a battery. And the war for a better battery is being fought in laboratories all over the globe. Hold that thought for a moment. Nuclear waste is the radioactive waste of nuclear power plants that no one once kept near their houses or even carried through their towns. The nasty stuff is poisonous and deadly. It takes thousands of years to degrade completely, and we keep producing more of it. In less than 2 years, you may be able to purchase a smartwatch powered by a radioactive diamond battery that will outlive you and your descendants for generations. The potentially game-changing battery comes from the San Francisco-based startup nanodiamond battery, which claims its eponymous high-power diamond-based alpha, beta, and neutron voltaic battery for providing lifelong and green energy to gadgets. Consider this: a single battery may operate your insulin pump or pacemaker for the rest of your life, or it could provide the juice for a space rover, collecting Mars regolith samples for decades without any human assistance. Those are ambitious goals. The nuclear diamond battery could be the solution to everything. The battery is on a whole new level, and it has the potential to change the world. There has been talk of never-die batteries. The high-power diamond-based beta, alpha, and neutron voltaic battery, according to the San Francisco-based company, is capable of providing long-lasting and environmentally friendly energy to gadgets, which would change the world. NDB claims to have developed a nuclear waste-derived self-powered battery with a 28,000-year life expectancy, making it ideal for your next electric car, Tesla phone, and other gadgets. The battery is made of 2 types of nanodiamonds, making it nearly crash-proof if used in a vehicle or other moving object. According to NDB, the nanodiamond battery is self-charging and environmentally friendly. Electric vehicles, mobile phones, laptops, tablets, drones, watches, cameras, health monitors, and even sensors can all benefit from the battery. It is also said to be extremely safe and tamper-proof due to its non-radioactive diamond coating, which prevents radiation leaks. The battery works by generating electricity on its own from a shower of electrons as a result of radioactive decay scattered and deposited in the artificial diamond case. The company intends to further purify the nuclear waste in order to increase the battery's power and use it to manufacture computer chips and nano devices. NDB intends to create a nanodiamond battery from the pure C14 nuclear waste. The NDB estimates that managing and disposing of 34 million cubic meters of global nuclear waste will cost more than $100 billion. And much of this waste is graphite, which is a high-risk radioactive waste that is also one of the most expensive and difficult to store. According to the company, its battery can power houses and any excess electricity generated can be sold to the grid. Furthermore, because the new battery does not need to be replaced, it can be installed in difficult-to-reach places such as pacemakers and implants, where regular battery replacement is not possible. Another application is in space electronics. According to reports, The battery powers space equipment and rockets. It can power spacecraft's electrical needs, such as providing power to cockpits and assisting with launch into the upper atmosphere. During this time, NDB can power communications, console controls, and any other auxiliary electrical needs. Once it is no longer needed by the rocket, it can be used to power satellites and space stations. The Lawrence Livermore National Laboratory investigated the proof of concept for producing NDB and discovered a 40% increase in charge efficiency over diamond. According to the manufacturer, the nano-diamond battery works as follows. The extraction of radioactive graphite from nuclear power plants involves several steps. Due to the danger of these removed radioactive remnants, they are currently disposed of. These items are placed in a container and thrown into deep sea or volcanoes to decompose, avoiding any live interaction. Radioactive graphite is treated and purified in order to remove it from the environment. Carbon-layered structures can then be used to create the batteries. Diamond nuclear voltaic batteries have two charge collection contact surfaces and are made of a combination of semiconductors, ceramics, and metal. Many units are assembled in the shape of a stack, with the same construction and positive and negative surfaces generated as in a traditional battery system, but with a higher output source. The radioisotopes in these batteries aid in an elastic scattering due to the presence of a single crystalline diamond in the system. At the same time, a polycrystalline diamond layer is applied to the stacks in the source. NDA will manufacture these batteries, which include several stacked diamond layers, a small circuit board, and a supercapacitor for collecting, storing, and discharging energy in a variety of common and unique sizes such as AA 18,650 and 2170. Long life appears to be possible with this battery. According to NDB, they could even be useful for spacecraft that need to operate for extended periods of time without assistance. Satellites, for example, are an example. As a side note, an average human would have died 400 times before this battery ran out of power, and more than 1,000 generations would have passed before this battery ran out of power. A consumer product is also being developed that could power a smartphone or electric car for more than a decade with no charge. According to the company, a single battery could power multiple pairs of wheels for up to 90 years, far exceeding the lifespan of any single vehicle. Aside from the convenience of not having to worry about charging our devices, this is an important step toward understanding the environmental impact of battery production and disposal. The product's safety is a major concern. Is it safe even though it generates power by the use of radiation? According to the official website of the NDB, the diamond battery features a very complicated safety system that addresses at least three of the most critical safety concerns. First, the polycrystalline diamond encapsulation may restrict the isotope's radiation while simultaneously protecting it from outside interference. Heat vents will be built inside the diamond battery to help regulate thermal conduction within the gadget. Furthermore, NDB will use a boron-doped single crystalline diamond to improve neutron radiation used by converting excess neutrons into alpha rays. Furthermore, the diamond battery will use an ion implantation approach to avoid nuclear proliferation caused by the generation of fissionable isotopes. This method also ensures that the diamond battery is only used to produce electricity. According to the company, the single crystalline diamond inside the battery is precisely positioned to minimize self-absorption of heat while allowing for rapid conversion to usable electricity. The company has yet to reveal the pricing of the lifetime battery. The NDB technology offers a wide range of applications. Recent advances in space technology, as well as the advent of the first piloted electric aircraft, have increased demand for their battery systems, which has been hampered by concerns about longevity and safety. The NDB can provide long-term power to drones, electric aircraft, space rovers, and stations. Smaller gadgets, including as smartphones and laptop computers, will use this technology in the future. Each includes a small power generator that will last as long as the gadget itself, without the need for recharging. In situ and implanted medical equipment, such as hearing aids and pacemakers, can benefit from lengthy battery life in a compact package, with the added benefit of safety and longevity. The business explained. It is important to note that the company has not yet created the battery, but in 2016, researchers from the University of Bristol published a proof-of-concept design dubbed Diamond Nuclear Voltaic that employs discarded graphite blocks. The startup hopes to begin selling the batteries to corporate partners, including space agencies, for long-term missions within the next 2 years. NDB is also working on a consumer version that will be able to power a smartphone or electric vehicle for up to a decade without having to be charged. Finally, unlike lithium-ion batteries, the radioactive nano-diamond battery, which is powered by radioactive nuclear waste, can operate for 28,000 years without having to be replaced. We'd love to hear what you think about nuclear diamond batteries in the comments, and thanks for watching the video. If you want to continue to learn about everything regarding Tesla or electric vehicles, we've got 2 more video options for you on the screen to check out. And don't forget to give a thumbs up on this video if you liked it and subscribe to our Electric World channel for daily content just like this.